So for problem A, they give you that f of x equals 3x squared plus 4x when x is less than or equal to 1, and 2x squared plus ax plus b when x is greater than or equal to 1. So we must find the values for a and b so that f of x is both continuous and differentiable. So to determine what values of a and b will make the f of x continuous, we must find where the limit as x approaches x for f of x from both sides is equal. So the limit of f of x when x approaches 1 from the left is equal to 3 times 1 squared plus 4 times 1, which is then equal to 7. The limit as x approaches 1 from the right of f of x is equal to 2 times 1 squared plus a times 1 plus b, which is equal to 2 plus a plus b. We set both of those equal in order to figure out to find if it's continuous there. To determine if it's continuous, to find those values when they're continuous. So the derivative same for the derivative. The derivative from the left must be equal to the derivative from the right. So the derivative from the left is 6x plus 4, and the derivative from the right is 4x plus a. And we set those equal to each other, and we plug 1 in for x. That is then simplified down to 6 plus 4 is equal to 4 plus a, which is then equal to 10 equals 4 plus a. To find the actual values for a and b, we can simplify a down to its value by subtracting 4 from both sides, that making a equal to 6. We then plug a into this equation to determine what b is. So we plug 6 in for a, and we get 7 equals 2 plus 6 plus b. We then can simplify that down by subtracting by 8 from both sides and getting b equal -1. So at the value for when a is equal to 6 and b is equal to -1, this function will be continuous and differentiable. The overall function would then be f of x equals 3 times x to the second power plus 4x when x is less than or equal to 1, and 2x squared plus 6x plus -1 or -1 when x is greater than or equal to 1.